All right, so welcome to Lab 1. This is analyzing signals and acquiring data. So just to give you a brief explanation of two of the tools we'll be using in the part 1 of the lab, we have the Tektronix arbitrary function generator and the Tektronix digital oscilloscope. So to start with the arbitrary function generator, which we'll use first, you simply press the power on button and connect the BNC cable to the channel 1 output. Once you have this connected, you can go through and you can press these buttons up here to change the frequency, amplitude, the offset. You can change the type of function it is, whether it's a sine wave, a square wave, a triangle wave, using these cursors down here. It's pretty straightforward. Once you have your function set up, you turn on the channel 1 output over here. So you press this channel 1, the light will turn green, and that will show you that the output is on. Once the oscilloscope is up and running, plug it into channel 1. So right now it's just loading. We'll continue with English. Let's see. There we go. So press any button. Right now you can see I have a sine wave with a 5-volt increment. So right now it's a 10-volt amplitude. Let's see. Let's auto set this to see what we're looking at. Yeah, so you see the distance between the vertical lines is 5 microseconds, and the distance between these lines is 5 volts. You can change that using this here. This volts dial changes the height of each line. That should be it for part 1. We'll start with the NI Elvis board. On the back here, you'll see a power switch. Make sure that one's turned on. And then using the prototyping board, you have to apply power here. So press that power switch on also. You'll see these lights turn green. You'll see the USB is ready. So we are done with the digital oscilloscope. So we'll take out that BNC cable. You'll notice that the sine wave goes away. And for the purpose of this lab, we'll be connecting to the scope channels in the Elvis board. So we'll connect the BNC cable to channel 0 in the Elvis board. That gives us an input channel. So now we'll go into our lab view, blank our VI and our front panel. So for this lab, in order to analyze the data, we need to go into our block diagram. Right-clicking anywhere on the screen, it brings up a menu. Go to Measurement, I/O, NI DAC MX, and then DAC Assist. Brings up the DAC Assistant tool block. Click and place it anywhere in your block diagram. When this initializes, it brings up the DAC Assistant, which tells you whether you can acquire or generate signals. So in this case, we're acquiring an analog input signal, and it's going to be a voltage. So we'll choose voltage. We have all these analog input channels. That's what AI stands for. So we have analog input channels 0 through 15. Right now we're using scope channel 0. So we'll select scope channel 0 and click Finish. So now it brings up the properties. So right now we have down in the bottom right-hand corner, we have the sampling rate, we have the number of samples to read, and the acquisition mode. So for this laboratory, we'll be doing N samples, where you can also choose continuous, 1 sample on demand, are the other 2 that we'll use throughout the lab course. But we have the N samples, samples to read, and the sampling rate. So once that's complete, what we can do is test it by pressing this run arrow up in the top. So doing so, we see that we have this sine wave, sort of a sine wave. I haven't programmed this yet to what you're going to see in lab, but I'm just showing you all the tools. So once you finish this, we'll press OK. So it'll build the VI, starting with the DAC Assistant. It'll initialize everything. Then in the front panel, what we'll do once this is finished is we'll right-click, we'll go to Graph. So we have Waveform Chart and Waveform Graph are the 2 that we'll use. Waveform chart you typically will use when you have a loop. In this case, we don't have a loop, so we'll use a waveform graph. And again, place the waveform graph anywhere in the front panel, and you'll notice over in the block diagram, the waveform graph starts here. And now simply all we have to do is connect the wires. So we'll have the data output here. We'll connect that to the input for the graph. And once that's complete, we can run our program, pressing the run arrow in the top. And you'll see we have the same sine wave as before. So you can play with that with the laboratory, changing the frequency of the input, changing the frequency of the sampling rate, and changing the number of samples to read to get a better data set. So for part 3 of the lab, we're doing filtering of signals. So going back into your block diagram, right click anywhere, and the most common thing you'll do is go to Express, and we'll see we have all these different options here. So we'll do signal analysis, and for part 3 we're going to simulate a signal, which again we'll put in here. So simulating this signal, we can change the type of wave: sine, square, triangle, sawtooth, or DC. Just for fun, I'll show you a triangle wave with a frequency of, I'll make it 10 or 100 hertz, just for fun. And then I can add noise to this. So right now we're having unfiltered noise with an amplitude, I'll make it 0.1. And I'll leave, and uniform white noise goes across all frequencies in the spectrum. So we'll leave that as is. Now you can see over here what the wave will look like. I'll press OK. And we're done with all this, so just highlight and delete that. Next, I'm going to put in 2 graphs to show you what part 3 of the lab will look like with this triangle wave. So I have 2 waveform graphs, and you can change the title of these as you see fit. Also, go back into the right-click menu, press Success, go to Express, go to Signal Analysis, and Filter. So now we're going to add a filter to this lab. So in this block diagram, we're going to create a filter. It's going to be a low-pass filter. So our cutoff frequency, so our frequency of the triangle wave is 100. So I'll make the cutoff frequency 200 just to be safe. Everything else should be fine. I'll press OK. You can play with those options as you feel. We'll go with triangle wave, connect it right to the waveform graph, and I'll run it just to show you what it looks like. Here's our unfiltered triangle wave. Going through, I can connect the wires to the filter, input into the signal. The filtered signal comes out to waveform graph 2, and running this, you can see the difference between the uniform white noise and the filtered triangle wave. So this might not be as clear as the lab you're going to do, but that just shows you how to set up part 3. And that should be it. Good luck.